This is an overview of your next assignment, assignment number 2. This assignment is about learning to use standard input, and it's also about learning to use arrays as well as math methods. Part 1 is a game called NumberHunt. Let me go ahead and just I'll pull that up in Eclipse. And here's how NumberHunt works. If you just run it with no command line arguments, it prompts the user, please guess a number between 1 and 100. And so the user guesses a number, and then it gives a hint depending on whether the number was close to the target or not. So 40 is getting warmer, 30 is warmer, 20 is colder. Let's try 35, 35, I don't know, 37, 38, 39. Maybe we should go the other way. 34, we're getting close. 33. So it gives you hints about what number, how close your guess number is to the target value, and it also tracks the total number of guesses and then prints out a congratulations message once you've reached a number. It's choosing a random number between 1 and 100 inclusive, and so it's not going to be the same number every time you run it. Alright. You can't do that, right? So you get invalid input if you enter something invalid. And I don't know, where is the number at, I wonder. 5, 4, that was 3. That's the first way NumberHunt works. The other way it works is a special mode in which you actually tell it what the secret number is. So I can specify a number like 42. Alright, make sure I'm running NumberHunt, and then run it. And then if I go to 42, I won in one guess. Brilliant. We're going to use this feature. You have to implement that particular feature just to help us in debugging your program, or testing your program rather. Here are the details about what kind of message you put. So obviously if you guess it correctly, you nailed it. If you're only one number off, that is you're adjacent to the target number, then you print on fire and so on. You have to handle invalid integer input. Alright, but you do not have to handle other kinds of input like strings or floating point values. You actually don't know enough in order to handle those cases easily. You should use standard in to get that input from the user. You'll need to put standard in your project. So if you look at my project, right, I've got standard in the directory with my Number Hunter game. You need to do that, so download that from the Princeton site or from the course homepage. You can see an example of how you use standard in to read integers in the order product example. You'll need to handle the case of whether you're drawing a random number between 1 or 100 or whether you're using the number set from the command line argument. You want to use the args.length field in order to test that. You can't go parsing args bracket 0 until you're sure there's actually something in args bracket 0. If you've forgotten how to draw random numbers, check out the 2 dice example, which shows you how to draw a random number between 1 and 6 inclusive. You'll need to modify that in order to do this 1 through 100. That's the first part. Second part, RadarContacts. This is practice not only with input but also with arrays. The problem is you're given a bunch of data. So we're pretending this data came from a AWACS surveillance aircraft, and this aircraft monitors radar contacts and tracks the position of those radar contacts and whether the contact is got a friendly transponder or not. You're going to read in the data from a file like radar 4. Radar 4, the radar data files always start with an integer, and that integer tells you how many radar contacts are in the file. Your first job in this program is going to be to read in the input. The first number is the let's see, 4 contacts, each the easting and then the northing. It's using something called the UTM coordinate system, which isn't that important other than you can kind of treat this like maybe an X coordinate and this is a Y coordinate, or so on. It's basically the number of meters to the east of some reference line and the number of meters to the north of some reference line. Those are the first two numbers, and then the call sign of the aircraft. It has a call sign like EJ475 if it's a friendly aircraft. It has a call sign of a question mark if it's an unknown contact, a bogey that may be a hostile aircraft. You're probably going to want to read this information into some sort of arrays, because what your program needs to do is take two command line arguments. So this is an example of a program that's not only reading from standard input, but it's also getting some input from the command line arguments. You can do both in a program. It gets two command line arguments. The first is a radius specified in kilometers, and this is how close contacts have to be considered sort of potentially, a threat to one another, or either a threat from a hostile aircraft or a threat from crashing into a another friendly aircraft. And then a mode. Mode is a number, and if mode is 0, the program is going to report contacts that are within a radius of another aircraft that are not friendly, so possible bogeys or hostile threats. If you set mode 1, it will return only friendly contacts that are within the radius, and if you set mode 2, it will list both friendly and potentially non-friendly contacts within the distance. How do you figure out the distance? Well, you can figure out the distance using the formula that's shown at the bottom of the web page. Alright, just the simple Euclidean distance. So if you take the difference of the x coordinates and square them plus the difference of the y coordinates and square them, add them together, take the square root, that will give you the distance. And there's a function math.square root to help you do that. Here are some example runs of the program. If you run it with a radius of 1 and say, please give me all friendly and non-friendly contacts within the radius of all friendly aircraft, none of those occur. Like none of these aircraft in this radar 4 are within 1 kilometer of each other. All right, and so pay attention to these are in meters, right? UTM coordinates are in meters, and the command line argument is in kilometers. If we increase the radius to 2, all right, it always prints out how many friendly aircraft and how many non-friendly aircraft, regardless of whether there are any things within radius of each other. At this radius, CX-120, our friend CX-120, one of our friendly aircraft, you loop through those and discover, there's a potential bogey that's within a 2-mile radius. And so it prints out a question mark for the bogey, because that's the call sign of a non-friendly aircraft, and then in parentheses it prints out the distance in kilometers to 2 decimal places. If I increase that radius to 3.5, now EJ475 is within 3.5 kilometers of the other friendly aircraft, CX-120, and CX-120 is in range within 3.5 kilometers of the bogey, as well as symmetrically EJ475. If this guy is within this guy's range, then this guy CX-120 is also within the range of the other friendly. If you use a mode of 1, and recall mode of 1 is only friendly contacts, and you run it for the same 3.5 radius, it's the same output other than CX-120 doesn't report the bogey contact. And if you only ask for bogeys, then the only listing is CX-120 and the non-friendly contact. You can download radar4.txt from the website. There's also a much larger file, 397. Once you think you have your program working, I suggest you run all these test cases and make sure you get the exact output we got. A couple things to pay attention to. If you find yourself with a string variable and you want to see, does this string variable equal some other string, maybe you want to see if it, for example, equals the question mark. How do you do that? Do not, under any circumstance, do that using the double equals sign. This is a dangerous thing to do. It may sometimes work and it may sometimes not work. It's not doing what you think it's doing. Eventually we'll talk about what it's actually doing. But for now, know that if you have a string variable, the string variable has an equals method. If you have a string called foo and you want to see if foo equals bar, the right way to do it is to do foo dot equals and then put the string you're trying to match in there. This expression returns a Boolean true if foo is exactly equal to bar, including case, and it returns false otherwise. If you've got a string variable and you'd like to see how long it is, you can call dot length on the string variable, and that will return the length. If it's completely empty, then that length is going to be 0. And a couple other things about output. If you find yourself needing to put a line feed inside a string variable, you can do that with a \n, or anywhere you've got double quotes. If you put a \n in a printf or a println or a print, whenever it sees \n, it puts in another line feed. You need to have your output to 2 decimal places in this assignment, and here's how to do it. The first bit here is if you're trying to print out a double value to 2 decimal places, here's the secret way to do it. We'll talk more later about all the different things you can do with this printf method. Alright, it's like println print, but more powerful. You can specify a special secret code %.2f, and what happens is this foo variable, which contains a double, gets filled in to that slot, that %.2f slot, and gets rounded to 2 decimal places. If you were to need to do that and not print it out and just store it, for example, in a string variable bar, you can do the same thing with a similar method on string called string.format. And I think that's all I have to say. Just make sure you first work on the input section. So the second part here is harder. It's going to take you, it's the most complicated thing you've done to date, so do start early. First goal should be to read in all your data into an array. You'll need to set up 3 parallel arrays storing the easting, the northing, and the call sign. And then once you have your data in there, then work on making the algorithm that goes through those arrays and prints out, first you can do something to print out the number of friendly and non-friendly aircraft, and then work on implementing the different modes.